everyone, so today we're going to go over lesson 8 of logarithms. This is the last lesson of the unit. So at this point you should be able to realistically answer all these questions, but I'm just here to show you how to break down each question into components so that way you're able to tackle it. So this first question I already finished for you, and this will be worth 1 mark, but I'm just going to be here just to break down how I got all this information. So here it says a colony of insects is growing exponentially according to the formula where P, population, is equal to 160 times 2 to the power of t over 3, where t is weeks. Find the population of insects at 4 weeks. Express your answer to the nearest whole number. So I always recommend students, and you've heard this in the past as well, you should always underline key information in word problems, and as repetitive as that sounds, it honestly helps a lot of students out. So here, find the population. Population, do we know this number? No. So that's what we're looking for. So P equals a question mark. That's our goal. Of insects at 4 weeks. So whenever you see a numeric value, not all the time, but generally, and especially in word problems, that means it's going to be representing a variable. So here at 4 weeks, weeks is represented by the letter T, so T equals 4. Express your answer correct to the nearest whole number. That means you're going to round it up. So this would be a calculator question. They wouldn't expect you to do this on your head. So here, we just plug in everything into our formula given to us, and then we see what we need to solve for. So on the right side of the equation, everything is filled out. There's no missing variable. But on the left side, we're looking for P. That means we just have to plug into our calculator and solve, and that gives us 403. So here, that means we have 403 insects at 4 weeks, and then since it's a word problem, I always recommend students write a sentence just to be safe so you don't get docked a random mark anywhere. So you would just say the population of insects at 4 weeks is 403. And that's it for letter A. So for letter B, this one's going to be worth 2 or 3 marks depending on the marker that year, or not marker, sorry, the exam that year, but generally 2 or 3. So here, same formula. Find the length of time required for the population to reach 1,000 insects. Express your answer in numbers of weeks, correct to 3 decimal places. So I'm going to let you guys pause for a second, and I'm going to ask you to underline what you think is important, and then resume the video after you finish and see if it matches what I say. So here, find the length of time. So find is a key word saying that's what you're looking for. Length of time. So what variable is represented by time? It's t. So here, oops, wrong one. Time, so t is equal to what? Required for the population to reach 1,000 insects. This is represented by the letter P. Express your answer in number of weeks, correct to 3 decimal places. So we need to have 3 decimal places this time. We're not going to round it up to a whole number. So now we just plug in into our equation and see what we're missing. So here, 1,000 P is equal to 1,000 equals 160 times 2 t over 3. So we're looking for the letter T here, and T is in the exponent spot. So as I said earlier in a previous lesson, whenever you see a variable in the exponent spot, that means you're going to have to use logs in order to solve for that variable. So we just need to get T by itself. How do we do this? So first thing is you want to get rid of the 160 because it's being multiplied by the base number that's attached to the T. So you're going to divide both sides by 160. Oops. Here, 160 divided by 160. And that gives you 6.25 equals 2 to the power of t over 3. Now at this stage, you should be able to use logs on both sides because there's just a base number attached to the t. So here, we use log. And what's our next step? So here, when we have the word log, we can now move our exponent to the front using the power law. So log 6.25 equals t to the power of 3 log 2. And then now we just use, or not yet, we don't use our calculator yet, but we think, what do we do next? We want to get t by itself, so we're going to isolate t. So in order to do that, we're going to multiply everything by 3 because of the denominator under the 3, we're going to multiply everything by 3, and then we're going to divide everything by log 2. So you're going to be left with t equals 3 log 6.25, because of the 3 moving, divided by log 2. And when you plug this into your calculator, you should get 7.932 weeks. So here, the sentence you would write is, it takes 7.932 weeks for the population to reach 1,000. And I always recommend students, make sure it does say 3 decimal places. If it doesn't tell you how many decimal places to have, you should always make it 3. That's just like a general rule. So here, that's it for this question. Now we're going to go to number 2. So a principal of 5,000 is invested at 3% compounded annually. The investment grows according to the following formula. How long will it take to make $500 on interest? So here, what are some key information you have? So here, a principal of 5,000 is invested. So this is your starting value. Whenever you see a percentage, especially in logarithms, you should always convert this to a decimal version of itself. So here, you would just do 3 divided by 100, which is 0.03. And this is another key thing for logarithms, especially for this type of word problem, is the word annually. So annually means n equals 1. And you'll see this in the listing of variables here as well, where n is the number of compounding periods, and here compounded annually, that just means 1. So that's one thing you should always look out for. Sometimes I might say semi-annually, but it's usually one or the other. This is where I recommend students to bring a dictionary, where if you're not sure which one it is, just pull it out and look for it in the dictionary. But anyway, the investment grows according to the following formula. How long will it take to make $500 on interest? So this is what gets a lot of students. They see how long will it take to make $500 on interest, and they're like, oh, that's going to be my letter A. That's the final amount. I'm going to make $500. No, it's saying $500 on interest. What does that actually mean? So here, it's saying you're making it on interest. That means you're making an additional $500 to what you started off with. So your letter A is actually going to be 5,000, your initial value, plus 500, the interest. And then now this is equal to the equation where you plug and solve. So P is the initial amount, aka the starting value, which is 5,000, times 1 plus R. What is R? R is going to be your percentage here. So R is going to be 0.03, that's your rate, aka the percent, divided by N, and N is going to be 1. Times N to the power of T, N is 1, and here T. So now I'm just going to put all this together. Or before I actually put everything together, right away, you're just going to divide both sides by 5,000. And this is something I want to address that I notice a lot with your group. So here, you can't divide the left side by 5. Wait, I just realized something. I should say 500. Oopsie. But anyway, so here, you can't you can't cancel out the 5,000s here because there's a plus sign separating these two. So the 5,000s don't cancel. So you actually have to add your numerator together. So it's going to be 500 plus 5,000 divided by 5,000. So you can't cancel the 5,000s out here. That's not how fractions work. So here, when you simplify this, you should get 1.1 equals 1.03 to the power of t. So here, 1.03 came from the bracket, 1 plus 0.03, and then I didn't bother writing the 1 beside the t because it's just invisible. Now at this stage, you're able to use logs. So log 1.1 equals log 1.03 to the power of t. And now, what do we do next? We bring the t to the front using power law. So it's going to be, write it here. Log 1.1 equals t log 1.3. And now t equals log 1.1 divided by log 1.03. And when you plug this into your calculator, you should get 3.224 years. And then your sentence would be, it will take 3.224 years to make $500 in interest. So again, just to go over really quickly what I did is we're making $500 in interest. So it's going to be your initial value, 5,000, plus the interest, 500. That's going to be your final product, aka A. And then you set up your right equation. And then you're just going to isolate for t following the logs procedure. But again, on the left side here, do not cancel out the 5,000s. That's not how mathematics fractions work. You have to add the numerator, then divide it by the 5,000. If this was 500 times 5,000, then you could cancel it. But because it's plus or minus, you can't cancel it. So that's it for the first page. Now we're going to move on to letter 3. Or not letter 3, sorry, number 3. So here, the largest lake lying entirely within Canada is Great Bear Lake in the Northwest Territories. So far, nothing really to underline. On a summer day, divers find that light intensity is reduced by 4% for every meter below the water surface. The situation can be represented by the following equation. So a lot of students will see 4%, and I know I said earlier generally that's what you use in the equation. And that is sort of the case for this question as well, but you're not going to use anything with this 4%, and you'll see why. At what depth is the light intensity 25% of the intensity at the surface? Round correct to 3 decimal places. So here, the equation actually uses the 4% for us. So here, it's being reduced by 4%. So what they did is they took a whole 1.0, and they minus 4% for it. So that's how they got to 0.96. So this question is actually kind of trying to bait students into thinking, oh, I need to plug the 4% somewhere. No, they already did it for us. If this said reduced by 25%, then this will say 0.75 instead. So you need to check, does the percentage relate to something directly in the equation already? If it does, that's a good indicator that they already used that number for you. So this is one of the more harder questions because it's kind of worded weirdly and there's like a lot of bait stuff in it. For example, the first whole sentence is like, it's cool information, but you don't actually use it in the formula. The 4% is trying to trick you. And what's actually, how it's worded is kind of tricky as well. So here, at what depth is the light intensity 25% of the intensity at the surface? So this is AKA, at what depth is it going to be where the light is 25% of the initial light intensity? That's the same thing. That's basically what it's saying. So to set this up, before we set it up, we're going to look at our variables, where I is the light intensity at distance d, IO is the initial light intensity, and d is the distance below the surface of water. So on the left side, we're looking for the level of light intensity, and we know we have 25%. So I'm just going to convert this to 0.25. So on the left side, the light intensity we're looking for is 25% of the initial. So you don't actually need a full numeric value of this. You could just write 0.25 times the variable that represents the initial value of intensity at the surface, which is IO. And now we fill our equation. We don't actually know what IO is, so we're just going to relabel it again. IO 0.96 times the letter D. So here, not times the letter D, to the exponent of D. And then now, what are we looking for? So it says at what depth? So here, we're looking for D equals question mark, and that matches our equation. We're looking for D. So a lot of students tend to panic. They're like, wait, but I don't know what IO is. I'm looking for 2 different variables. Does it matter if you know what IO is in this question? It doesn't, because on both sides, IO is being multiplied and there's no other plus or minus sign separating anything. That means you could actually cancel out the IOs. So you don't even need to know the actual value. So now it's going to look like this. 0.25 equals 0.96 to the power of D. And now this looks like a similar log question we've been seeing over and over again. So following our procedure, we used logs. And then from here, we use the power law. And now we just isolate for d. So d equals log 0.25 divided by log 0.96. And when you plug that in, you're going to get 33.959, 3 decimal places. And what's our unit? It says depth, and depth is measured in meters. And it says that somewhere in the question, hold on, let me find it, for every meter. So you have to find out what unit is used, and you have to include it in your answer. The sentence here, you would just say the depth is 33.959 meters. That's fine, like you just say that. So we're almost done the lesson. We have 2 more. So this next one's probably the hardest one in terms of mathematics because it's going to be a double-step equation. And I'm going to explain to you in a bit how to identify if it's a double-step equation. So here, number 4, the fish population of northern Manitoba Lake is modeled by the function p equals 5,000 times 1.02 to the power of kt, where p is the population after time t equals the time in years, t is greater than or equal to 0, k equals the rate of growth. So here, if they don't tell you that you're working in time, and they shouldn't even tell you that t is greater than or equal to 0, because realistically, if you have time is equal to a negative number, that doesn't make sense. You can't time travel. So in general, even if they don't say it, I highly doubt they would say it on the exam, honestly. Like they wouldn't tell you t is greater than or equal to 0. That's just something you should know. It's like a logic thing. And the same thing with any other variable, like for example, height, time, stuff like that. Like you shouldn't have a negative number. But anyway, so here, after 3 years, there are 5,300 fish in the lake. Determine the number of years it will take for the population to grow to 15,000 fish. Express your answer correct to 3 decimal places. So here, underline all the key information. So after 3 years, there are 5,300 fish. Determine the number of years it will take for the population to grow to 15,000. Express your answer to correct to 3 decimal places. So whenever you see that they gave you 2 information about the same variable, or if they gave you a case scenario and then ask you again to find a variable they're going to give you another case where they give you the same variable value. I know I worded that badly, but wait, let me restart that. So here, they gave us one scenario. After 3 years, there are 5,300 fish. So here, they told us t equals 3, and p is 5,300. So they gave us t and p already. And then again, they ask us to find the number of years. So we don't know what t is. We're looking for t. But they told us the population is now 15,000. So here, what I was trying to say earlier is they gave us 2 numeric values for the letter P, and they gave us a scenario originally, and now they're giving us a new scenario with variables we've seen before. That's generally a good indicator that's going to be a double-step equation. So again, they gave us 2 different numeric values for a variable. So here, I'm just going to break up my page. So my left side is going to be represented the scenario they gave us, and then the right side is going to be our end goal. So on the left side, we're just going to plug in everything they gave us. So 5,300 equals 5,000. So they gave us t, so that means we're going to look for k. So to do that, we're going to get rid of the 5,000 on both sides. That gives us 1.06. Now at this stage, you can use logs. And then now we could use the power law. So log 1.06 equals 3k log 1.02. That's an ugly k, but that is a k. And now when you isolate for k, it's going to be log 0.106 divided by 3 log 1.02. And that would give you 0.9808279.015. Do not round at this stage because we're not looking for k, we're looking for t. But you need to have all your decimal places because we need all the decimal places in order to find out what t is in the second part. So here, now we're just going to plug in everything we know for the right side. So this is like our end goal equation. So 15,000 equals 5,000 times 1.02. At this stage, you don't actually have to write down the numeric value of k, especially because it's so large. You could just write k again. Because we wrote at the bottom here, k is equal to this number. So we've stated that we know what k is. And this is just to save time and space, honestly, from rewriting it over and over again. You just need to write it at the very end when you're isolating. So here, you're going to divide both sides by 5,000. So 3 equals 1.02 kt. And again, we know what k is. We're just writing k because we don't want to write that big number. And then now we use our log rules. So log 3 equals log 1.02 kt. Power law, so log 3 equals kt log 1.02. And now when you isolate for t, it's going to be t equals log 3 divided by that big value, so 0.9808279.015 times log, as a time symbol, log 1.02. And then now, when you plug that in, you're going to get t is equal to 56.563 years.